asks us, given that it's dry on Monday, so the same condition, what's the probability that it rains on Thursday? Again, I've copied out my law of total probability, and this time we're looking for the probability that it rains on Thursday. So I'm going to put that one in here for event B. Rains on Thursday. And it equals the probability that it rains on Thursday given doesn't rain on Wednesday times the probability doesn't rain on Wednesday plus the probability of B given A dash, probability that it rains on Thursday given it rains on Wednesday, times the probability it doesn't rain on Thursday. Sorry, that last one is doesn't rain on Wednesday. So event A is Wednesday, raining on Wednesday, event B is raining on Thursday. Substitute some values in. Probability that rains on Thursday, given that it hasn't rained on Wednesday, is going to be this 0.4 again, times the probability that it doesn't rain on Wednesday is, this is a probability it does rain on Wednesday, so the probability it doesn't is 1 minus 0.52, which is 0.48, plus the probability that it rains on Thursday, given that it has already rained on Wednesday, which is 0.7 again, and the probability that it doesn't rain on Wednesday hang on a sec, I've got two probabilities of doesn't rain on Wednesday, one of these is missing. This one here is just B given A, so just B rains on Thursday given rains on Wednesday. So make sure you take off that dash there. So this one is actually 0.48 and this one is 0.52. Put this into the calculator and you should end up with 0.556, which is the probability that it rains on Thursday. Now, you could have chosen to solve this problem using a tree diagram, but because it ends up with 3 different options by the time we get to Thursday, it gets quite large. So here's one just to show you how it could work out. I'm going to label, this will be Monday, Tuesday, Wednesday and Thursday. And we could have it, well, we know according to the question that it doesn't rain on Monday, but then on Tuesday it could rain or not rain. On Wednesday, if it rains on Tuesday, it could rain or not rain. And on Thursday, rain, not rain, rain, not rain, rain, not rain, rain, not rain. Now we need to add some of the probabilities in. So if it doesn't rain on Monday, the probability that it rains on Tuesday is 0.2. 4. And the probability it doesn't rain is 0.6. My pen's having trouble filling in the decimal points, but hopefully you get the idea. There are decimal points in between there. If it rains on Tuesday, the probability of it raining again on Wednesday is 0.7. And the probability it doesn't rain is 0.3. If it doesn't rain on Tuesday, the probability that it rains on Wednesday is just going to be the same as these two. 0.4 and 0.6. If it rains the day before, the probability of it raining again is these two. If it doesn't rain, the probability of it raining is these two. If it rains, probability of it raining again, these two. And the last two are similar to these two. And you could write out all your events, so you'd get doesn't rain on Monday, and then rains, rains, rains. That'd be rains Tuesday, rains Wednesday, rains Thursday. And you could work out the probability of this happening is 0.4 times 0.7 times 0.7. Which equals 0.196, and that's just for this first one up here. You could do that for all of the outcomes down here. Or rather, if you were looking for the probability, like we were in this question here, the probability that it rains on Thursday. So you need to look for all the outcomes here that has it raining in the Thursday column. So you're going to have this one, which is this one, and this one. So you would need to work out all of these four probabilities and add those four up, and you will get, I'm not going to waste your time going through and adding them all up. If you'd like to, you can check, but you will get 0.556, which is a probability that it rains on Thursday, which is exactly the same as what we got using our total law of probability. So up to you. If you prefer to draw tree diagrams, you're welcome to use that method, or you can use the total law of probability. Now, I do just want to mention at this point that some of the work in the textbook involves transition matrices. Those questions are not needed at all. That's a further method we could use to solve these problems. You should still be able to solve all of the problems that are given in the textbook, but if it says draw a transition matrix or show the transition matrix you would use, then you don't need to bother with that question. Won't be examinable, and it's not in the course for this year. Thanks for watching the video.